Yep, I'm here today to talk about application of neural networks to actually for fuzzing web apps. Obviously, it is super important things now to apply neural networks everywhere. So I don't know, inside some kind of obvious things and not so obvious things, and fuzzing is super complicated task, and it is super easy to start fuzzing, to apply some kind of techniques, but it is really hard to reinvent this area, apply new ideas, and find new results. Even more, everybody using the same fuzzing approaches with different results, which is really cool. I tried to apply machine learning, technically neural networks to generate payloads here, and try to explain something like what is the fuzzing is, what is fuzzing of web apps, and what is the difference between like fuzzing binaries, for example, and web apps, what is the same, what is the difference, how to apply neural networks to fuzzing, how to fuzzing using neural networks, and some sort of combination of these things like fuzzing networks using web neural apps. So let me please explain myself and from where I am. So actually, I founded my first company in 2009, a security consulting team, and we actually conducted about 200 security audits since last, I don't know, like 7 years, even 8. And I'm also a bug bouncer, and I really like to find some bugs using some kind of techniques like fuzzing. So because it is super nice to be able to have some money through bug bounties, and so my total bounty is about $1 million last, I don't know, 5 years, 7 years. It's my Medium on Twitter. Just find me if you would like to follow me. I'll try to explain all the things regularly inside my Twitter and Medium accounts. So as I mentioned, I'd like to talk about fuzzing for web apps, fuzzing for neural networks, and how to combine all these things together in a right way, not in this way, obviously. So let's start. Let me start with the definition of fuzzing. What the fuzzing is. The main idea is super easy. Just try to run the program with some sort of input data to cause an exception. Try to analyze this exception somehow. Try to analyze the results and try to make it repeatable, obviously. Try to understand the reason of this crashes or some sort of other exception and all these things. And technically, fuzzing is a way how to generate this some sort of input data. How to generate something unexpected for the app, for the program in general case, how to generate something really important for attackers, something unexpected for the app, and how to repeat the success, and how to generate new payload, new like unexpected thing using the same and already known things. We can call fuzzing this technique to generate data, and also we can call fuzzing as we can use the same word like fuzzing as a process of this. Obviously, it is different terms, but when people talk fuzzing, it could mean generate data, generate payloads, and at the same time, it could mean all the process. How to analyze data, how to send it, how to clusterize all the things to be able to do it faster, and how to analyze the results. But in my point of view, in this paper and this like talk, I mean only like this payload generation things. So, why it's really important to use fuzzing techniques? It is really important because technically this memory allocated to the input data is really huge. When you would like to fuzz something like, I don't know, Microsoft Office or some kind of other binary program, you probably would like to use, I don't know, some kind of input files or something, and so this files contains of some sort of bytes. For the web apps, this is not a files but HTTP request with some sort of parameters inside, and each of them have some kind of length, and this memory is really huge. It's impossible to try anything, try to use like binary fuzzer and try each variant of this. But how huge is this memory? Really, even 4 bytes is really huge. 4 bytes means about 4 at 10⁹ variants, means 11 hours at a speed of 100,000 variants per second, means RPS in terms of black box fuzzing network, which is really huge. It is really rapid to send requests with 100K requests per second. So for even if you have some sort of testing environment, if you would like to create this kind of performance and run this test with the same speed, it is really hard to create this environment. Trust me, I try to do it so super frequently. And even 4 bytes is really huge here. Obviously, when we talk about some sort of independent parameters, so let's try to figure out how it looks like for HTTP requests, because I'm talking about fuzzing web apps, which means that we are doing with HTTP. One HTTP parameter contains about 100 different input parameters. If we would like to fuzz all of them with intersections, which means that one parameter could affect another parameter, we should spend about, I don't know how long it is. It's definitely biggest number than this time of our universe from the day one to nowadays, and so it's impossible even for 1 byte. But if we try to suggest that parameters is independent from each other, it's definitely possible to solve in a few seconds. And I really like this approach to fuzz anything and then apply some sort of neural networks to do some kind of other job to help us to identify some things. And some numbers from real life. I'm not sure that it is super important to describe some sort of POC or studies with no any practical applications. My goal is to suggest something with results, something with ability to be applied and practice. And this practice, in my experience, says that we have about, in general, for some sort of average application, about 100 HTTP endpoints with about half an hour, 100 HTTP parameters each, and so average speed could be about 1000 RPS. It is reasonable speed. I'm not sure that we can do more for average case because it requires a lot of resources, it requires a lot of different things. And even architecture of this fuzzing should be completely different. So, and 2 bytes, half fuzzing, a really good technique. It could cover Unicodes and some sort of combination of things, and it's possible to fuzz this application this way for about 92, 91 hours, which is reasonable, which is solvable problem, and so we can solve these things. We can apply some sort of optimization there. For example, I don't know, cut some kind of bytes from 7F to FF because it's almost the same for the apps, and we do not expect anything like unexpected there. We can cut all of them. We can apply some sort of dictionaries or other optimization to reduce this speed, to reduce this time, to increase the speed. So the difference between the fuzzing and this classic payloads inside the tests, like, I don't know, Econetics or Burp or FuzzDB or other things, as the coverage is huge. It's almost impossible to find new sort of vulnerability using old techniques, which is super obvious. But how to generate this like new payloads using other things. It's almost impossible to generate new payloads with other techniques instead of fuzzing. And so good thing there is it's possible to use existing payloads and apply fuzzing to generate something unexpected and to find something new, even for the web apps. We try to increase the coverage. We try to apply all the things. We applied some sort of typical fuzzing like 1 or 2 byte fuzzing, and it's reasonable. And then we would like to apply neural networks to increase this coverage again. Actually, we have the three main problems of any fuzzing, and especially for the web apps. We should understand where we should apply the payload, which means that we should analyze the data, we should analyze HTTP requests, and find right place to put the data. We should understand what is the payload and how this data could look like in particular field to be able to do something. And we should understand how to identify an exception, how to identify that our payload caused some exceptions there. I tried to explain this as a baseline of any fuzzing techniques and then go to neural networks and how to apply them and show you some results. So first problem is where. The coverage problem is really, really important. So a lot of security tools like scanners using these crawling techniques. It is the worst part of the scanning because in this case, the scanners try to emulate browser, which is almost impossible if you would like to use APIs, if you would like to use modern single page web apps, it's impossible to crawl them. It is possible to create units or regression tests or functional tests to increase the coverage and then put this test to the fuzzing. It's super, super robust part. And I'm really, really happy to say that it's trusted way. And if you already have some kind of tests, it is really cool for you to try apply fuzzing techniques to the existing tests. It's definitely better than try to crawl something. In this case, we should know that this HTTP protocol, technically, it's not only this level 7 HTTP data format. We should apply additional application logic things like JSON, XML, base64, some sort of encapsulation formats. For example, when the base64 encoded data puts inside JSON, and this fuzzer should understand all the situation and should be able to replay and create this and actually peg these payloads in the proper format. This is a really huge problem. This problem can sacrifice any benefits from any fuzzing, because if you would like to find some exception, you should run this application in the right way. To run this application in the right way, you should understand how this data should look like. Another one important thing here is custom encoding and encryption. Obviously, it's impossible to cover all the stages. It's impossible to protect anything. It's impossible to hack anything. It's possible to hack anything, actually, sure. It's impossible to find any method to call this app because you have no access to the mind of the developer. You have no access to, you have an access to source code sometimes, sometimes not. So, but you have an access to understand how it should work and so how custom data format could look like. I'm not sure that it's possible to solve this problem in some sort of way, but fuzzing also can help us there because sometimes fuzzing works well even with this unexpected data types with no any ideas how to decode it. Just because of this data fuzzing, it's obvious thing. And last one is the application logic and different things, because we can split all our activities to application logic fuzzing and input data. and fuzzing for some sort of input validation attacks. I'd like to describe only the second one. I'm not sure that it's possible to cover business logic things using these fuzzing techniques because I'm not working on it right now. So I'm just trying to explain only one way to fuzz apps and how to generate this data. So second problem is what? How to generate these attack vectors and how this unexpected data could look like. All the known attack vectors are already existing inside application scanners, vulnerability scanners. It is super easy just to have an access to these databases and apply all of them to the web apps and find something, but generally find nothing. Second one is how to generate this how to generate this unexpected data is just to use some sort of random or just try to apply each byte from 0 to FF in case of simple fuzzing, 1 byte or 2 byte fuzzing. It's possible. It's a really useful thing. So I just recommend to use this technique if you have time and in case when you would like to increase your coverage and find new issues. I'll show you some example in next couple of slides. New vulnerabilities means new payloads. It is a really important thing because I'm not sure that we can call something like the same SQL injection in different like API methods as a 0-day. Technically, it's not a 0-day. We can call it like 0-day for particular app, but not. It's not like a 0-day in general case. And so all this input validation things means new payloads. And we again have the same problem to determine what is the behaviors and how to identify business logic things. I have no any proper answer now, and I'd like to describe and explain only this input validation things and how to generate this input validation payloads using neural networks. And the last one, how to interpret the results. Sometimes things could look like same. For example, this poodles looks like chicken, this like dogs looks like this cakes. It looks like same, but with different results, which gives us false positives, obviously. If you try to run SQL maps sometimes, or other fuzzer, or other scanners, or fuzzing techniques, you definitely know what I'm talking about. Sometimes it's possible to cause a crash inside the app, but not because of your payload, but because of your like performance of your scanner or fuzzing. And it's possible to just take off the web app using some sort of scanner, and all the checks will notify you that so you already created the app. We are like winners. We can run SQL injection payload based on time base now. We can steal some sort of data, but it's not true. And it is also super usual task for machine learning to automate this kind of problems, but it's not them of this like talk. I just would like to talk how to generate attack payloads using neural network, and that's all. It's not super hard to clusterize traffic, to clusterize responses, to make some suggestions how the normal data and normal responses could look like. And probably I'll do this in future and add the same approach to the same fuzzer, but so I'm not working at the same thing yet. And so, and this like, so problem of how to reproduce this situation and how to create some kind of repeatable stage, repeatable payload, and repeatable results is also important and also included in this thing. So we have 3 main problems in fuzzing. It's where, what, and how. And this talk only is about what. So how to generate payloads and how to use the neural networks to increase the coverage. So now I try to explain how this architecture of this fuzzing tool could look like. To solve this problem with where we should put the payloads, I suggest to use just simple proxy and so analyze manual tests, manual requests, requests from some sort of automated tests and all the things, and catch these requests and apply some kind of fuzzy or AI-generated payloads there and send it to the application. It's possible to collect all the requests by tests. It's possible to apply all the fuzzing policies, including neural network policies. And it's possible to generate so a lot of tests. At my point of view, so the good multiplicator here could be 10,000, and run all of them and try to understand the results. And it's possible to crash the app in this way as well, as always. So, where a problem should be solved by just proxy, and I believe that it's only one useful way. If you working with web apps, you know that burp and this idea to repeat some sort of data using burp, run intruder, apply some fuzzing techniques there is really works well. To solve what, I suggest to use neural networks here and to analyze the results and to solve this like how problem there. I suggest to use nothing actually, just your mind. And how to fuzz. My personal top 6 fuzzing techniques for the web apps is try to modify last byte, like try to apply each of them from 0 to FF. Try to modify random byte inside your strings with the normal data at a proxy. It really works well. Try to add new byte at the end, like what, and try to apply parameters from one endpoint to other endpoint. It really works sometimes. So number 5 is try to play with numbers. If you see some kind of number, try to increase or decrease this number. And last one is try to apply some kind of existing file names. For example, from our fuzz.txt project available at GitHub to identify some kind of, I don't know, data, or just find some files at the folder or its root folder or somewhere. And I can claim that all these things could be covered by neural networks now, and it's possible to generate all these payloads using neural networks. Even more, it is possible to apply the right payload in the right case. For example, it is when we are working with some sort of web app manually, we definitely look at the normal data, right? If you see that somebody, like application or other user, already put some sort of HTML text in this particular field, and it's normal for the app, I'm not sure that it's reasonable to put some kind of XSS payloads there, because it is normal behavior, and obviously, so this app just was created to have some sort of HTML data in this field. If it is like PHP-MyAdmin or some kind of SQL administration panel, it's definitely a bad idea to apply some sort of SQL injection payloads there, because it's normal function to this app to have some sort of SQL commands in this particular field, and it is possible to put all these things inside the fuzzer and apply neural networks to do not do useless job. So, a few words about neural networks. It's super obvious. So I really so sure that you already know what is it. So some years ago, a few years ago actually, people started to apply neural networks widely, and this is idea to put some data, connect some sort of objects called neurons with ability to do some sort of super easy job to pass signals through in case of combinations of inputs or do nothing. And so funny thing there is if you would like to connect many of them, the results could be unexpected by the quality. It's impossible to, we have no any theory now why this neural networks works well. It's possible to, a lot of people just try to explain how it works and why the results could be like unpredictable good, but anyway, it works, and actually it's only one thing which we should know to apply some sort of techniques. It works, and it works well. For fuzzing techniques, since our goal is to try to generate some kind of unexpected, it is even not required to be sure that some sort of techniques works well to apply it at fuzzing. If you would like to use your cat to generate some payloads, you should do it. Just because it works somehow. It could work well or not, it doesn't matter in terms of fuzzing, do anything. So because of the fuzzing, it's like super obvious thing. And so obviously to be able to generate something with a context, we should apply recurrent neural networks. The difference is it is our way to put unrestricted data, like data with no restricted size. I don't know. Obviously, our fuzzer should be able to generate 1 byte, 4 bytes payloads, I don't know, 60 byte payloads with no modification, right? And to solve this problem, we should use recurrent neural networks. We have no any other way. And for example, it's possible to generate payloads by byte, and it's my approach. And so I believe that it's super useful thing. The difference is neurons inside recurrent neural networks have this ability to store some sort of data and call themselves. And we have actually different ways how to create these recurrent neural networks using some sort of existing frameworks. Let me please explain how to do it. First one is LSTM, or long-shot memory unit. Where's my pictures here? Anyway, so just visit the link if you would like to know more. These things have 3 JATEs. JATE means some sort of variable to store a number. And in some cases, when the input data can trigger this gate should do some sort of job. In long-shot memory unit, recurrent neural network, we have 3 JATEs. 1 JATE for input data to open and so close this ability to receive data from input. It is forget gate to be able to forget all the information about previous states of this network. And second one JATE is output gate to be able to open or close this ability to like generate data from this. It is super old-fashioned way to create neural networks based on these recurrent things. Before this LSTM, people just tried to apply vanilla recurrent neural network with no memory at all, and so it was super cool to solve simple tasks. But if you would like to solve some kind of situation with the states, I'll show you in a few slides how it looks like in fuzzing. It's impossible to use vanilla recurrent neural networks, and people just using something with the memory. We should do something with the memory, and it's obvious. And so second one way is to use a JATE recurrent unit. So a few years ago, I guess 2 or 3 years ago, oh no, it was at the end of 19th. Some really smart people suggested to do you know what? Just cut 1 gate here. We have 3 JATEs. To be faster, we should cut 1 gate. It is super cool thing. We should reinvent a little bit structure of 2 different gates. And so we should apply new training techniques to be able to train these things. But GRU is kind of LSTM with 2 gates. And so we have update and reset gates here. Reset gate is kind of forget gate, and update gate is a kind of something between input and output gate. It is faster, and the results and the quality is almost the same as LSTM. And this year, TensorFlow released new way. Do you know how? They just cut it another 1 gate. We have update gate RNN now with only 1 gate inside. It's something at the middle between vanilla recurrent neural networks. There's no gates at all. And so LSTM with 3 gates. Only 1 gate called update gate. It's not like update and reset gate. It's 1 gate, 1 gate with ability to store data, to store the state and to reset the state in some case. The main idea is when we have no to store, we are able to reset the state. It's a super obvious thing. It's available since last version of TensorFlow 1.3, and it's easy to train for high-stack architectures. And just Google reads this paper and so explain us how this like UG RNN could look like to make this training process for high-stack recurrent neural networks faster. And so, as I mentioned before, it's some kind of compromise it's kind of something between vanilla RNN and LSTM. So hackers always use this compromise word. So now we should suggest how to apply all these knowledges about neural networks, recurrent neural networks, and fuzzing inside the fuzzing. To solve this problem, we should create some kind of topology or architecture of these neural networks. Obviously, we should analyze which sort of data we would like to generate. Since we would like to generate some sort of payloads, which means some sort of syntax constructions for different languages, we should know how this language could look like. And language obviously means grammar. And grammar obviously means Chomsky hierarchy. And to be able to work with neural networks and to be able to cover some grammars, we should create this model. We should think how our network could look at the data. My suggestion is to be like a compiler. We should think like a compiler to create a neural network, and this neural network should also think like a compiler. Our neural network should analyze bytes on input layer, generate lexems inside, means tokens, to be able to combine sequences of bytes to tokens, and then combine these tokens to token constructions at syntax layer or like syntax phase of training, because layers is something different inside neural networks. And then this neural network should be able to apply some kind of semantic to be able, is it like reasonable payload or just kind of combination of tokens with no like important thing inside. To create this, I suggest to do something like this, put byte inside our neural network and create this topology with shift inside. For example, to store, I don't know, super obvious union token for SQL injections. It's kind of union select injection or a classic SQL injection. We are able to put first byte, and this byte can have an access to second one, looks like Markov chain, so, or something like this. This second byte could have an access to and a link to third byte, and finally we will have this token, like union. And it's possible to train the network by data to store this information with no any like hard coding tokens or anything, which is really cool to fuzz something, because obviously if you have a lot of payloads, it's impossible to analyze each of them manually and do something. At the second stage, it's possible to combine these tokens already constructed by previous layer, previous phase, previous anything, and create some kind of intersection and links between them. And for example, to store inside neural networks that select token should go after the union and some kind of column token should go after the select, then we should have from token and table token, all these things. And now we should understand from where we should download this train sets. My suggestion is to use this super cool GitHub project called SecLists, because inside this project we were able to find this fuzzing folder with a lot of tests for fuzzing and a lot of payloads inside. I also using the SQL map generated payloads because Miroslav Stamper is a really cool person who created this super incredible tool, and it's possible to run SQL map against my web application to catch the traffic and to actually steal the payloads from SQL map. I should mention there that it's impossible to train neural network in the right way using this template of requests, because this network should learn the structure, right structure of payloads. If you would like to train the fuzzer in this way, you should apply payloads instead of these templates of payloads. It's impossible to use macroses because your neural network in this case will generate these macroses. And to be able to extract some sort of payloads from SQL map, it's definitely better to just create some kind of vulnerable app and run the SQL map across this web app, and so put all the requests inside logs and then catch payloads from there. And I should mention that when you would like to do this, you should pass your SQL map through application with existing vulnerability. It's really important because SQL map, as well as other tools, as well as Economics, Burp, and other like scanning tools, have a logic inside. And if you have no vulnerabilities there, and so no responses will come to different things, like basic checks, these tools will not apply new payloads, new templates, new checks. To be able to steal all the data from these tools, you should create existing vulnerability. Even more, to be able to steal all the database, you should create different SQL injection for different databases, because some sort of this payloads depends on the structure of this databases, on this like type of vulnerability, different payloads for Oracle, different payloads for DB2, different payloads for MySQL, and all this stuff. And we're using our self-collection since we have some sort of data because of our clients. It's possible to put all of them here. It's kind of honeypot actually, so for us. Ta-da! And so let me show you some results. I trained the network to store some sort of local file inclusion permissions, local file inclusion bugs here. And this is number of step of the training. This is number of epoch. It's kind of batch things. It's value of error, and so we should increase in this value to be able to generate something. And this like example generation. At the first stage, when I just put some kind of like half of 1,000 steps, generated payloads looks really shitty. So, but we continue to train this network, and second generation is definitely better than previous one. It looks like some sort of files, right, with the slashes, but with some unexpected file names there. So since I have no any like URL encoding optimization there, I'm sure that proper fuzzer should know all these things inside, and so proper fuzzer should be able to generate even like encoded data here in case of plain encoding Second generation, third generation definitely looks better. At next generation, with error about 1, so after about 100,000 steps, we even can see some kind of recognizable by our like hacker mind things like etc folder, http, something like, I don't know, htaccess or something, etc.sc, which is something, I don't know, some sort of DE means, I mean, I don't know, like maybe DV folder or something. Next generation, so after after about 100,000 with a half, so steps with error roughly about 1, we can see even these names, reasonable file names inside this folder, etc folder and host name, which is really looks like payload, some kind of access log, some kind of etc host with no hosts. And after 2 million of steps, with really low error, we see something like really existing local file inclusion things. So, which means that it works, that it's possible to create some sort of neural network, recurrent neural network with the same topology. It is possible to create the model, how this like syntax could look like, how our fuzzer should store the data, put all of them inside the recurrent neural network, train them using payloads, and generate some kind of payloads based on these things. But what is the difference between these things, this approach, and just a list? I can generate these payloads byte by byte. Means that if I have some kind of response to etc folder, some kind of unexpected response, I can apply and generate valuable payload for this context with I don't know, existing and so file names in this folder. For local file inclusion payloads, it is possible to solve the same thing by, for example, decision trees or just sort of files inside some folders. But for complicated syntaxes like SQL or XSS, it is not so easy. And it's not so easy to apply and suggest new payloads. And it's not so easy to even to keep in mind each files inside this etc folder. And it's not so easy to put all of them inside a list and apply this logic into your scanner. It's definitely better to just put into the train set and train neural networks and so ask them to generate these payloads. And the results could be definitely better. And last stage is analyzing the results. Scanner produce vulnerabilities and false positives, and fuzzer produce subnormalities, and we should analyze how to analyze this data, and we should analyze who will do this work, machine or like human. And so my suggestion now is just to apply some sort of manually predefined testing policies. For example, when I try to fuzz something, I'd like to set some policy, for example, to have no 400 error codes responses, or just have no 1+ millisecond response or something like this. But in the future research, I'll try to solve this problem using neural networks as well. And now it's time to show you some results and identifying vulnerabilities. First example, it is a super obvious thing identified in Nginx using these fuzzing techniques. And I just tried to validate my approach. I just tried to put all the payloads available for different things and founded by, which were found by fuzzers to my neural network things, to be able to validate this neural networks works with the same accuracy and try to suggest something reasonable. I tried to put this payload inside neural network, run first generation, first byte generation using this like 0 byte, and understand that neural networks try to suggest more and more new data to the 0 byte to repeat the success with memory corruption and steal some data. It's this case covered by neural networks trained by some sort of data, but it's obvious thing. It's possible to generate these payloads using only the 0 byte, but it works. Second example, it's kind of server-side request forgery vulnerability inside method field, and I tried to figure it out. Is it possible to train network to suggest valuable things with this like character to be able to create some sort of things like parts of URLs to construct valid URLs with no 0 bytes, with no like pound things, some sort of reasonable things there. And it's also possible. I just trained my network by URLs, and when I put it so as its initial vector to neural network first generation for one byte fuzzer, that it's possible to have some abnormality using this byte, means like ampersand. This neural network started to generate valuable payloads with words and this character as well. And constructions were in the same way with pound, with ampersand, with this equation symbol, and with different like data from URLs with words here and with value here, which is really cool. Third example is this one. When I put a trained neural network by shell commands and put this new line character inside this XML request and try to generate some sort of payloads based on this initial character and this initial string, neural network started to suggest at me some kind of reasonable commands to shell, because they started from this context with new line. Obviously, they started to suggest me some sort of memcached injections, key value injections, and other syntaxes with the same termination byte, but it was. And so, which means that it's possible to cover these things with no knowledge of the structure of syntaxes, which is really cool. And the last one was my bug for Facebook. I don't know, like maybe 2 years ago, I suggested to run fuzzing across different bug bounty programs and found this super obvious thing with anomaly at Q parameter at researchfacebook.com. And that time I just started to brute something, and at my like human mind, it was like SQL injection because of this double quote here, but it was JSON suggestion. It was a JSON injection, and so I just missed this, and probably I missed my RCEs that time, but I tried to apply this neural network approach in this way and understand that this byte addresses neural network not only to SQL injection payloads, but also to JSON injections, because it's a terminal byte for SQL injection and JSON injections as well, which is really important. And it was super cool for me to understand that this network actually was smarter than me, because that time 2 years ago I missed my RCE and huge reward, because I suggested this this is like unexploitable SQL injection thing, but it was JSON injection inside Elasticsearch with ability to run a code because of some sort of vulnerabilities inside this Elasticsearch. So, and the last one is memcached injections. I just talked about these things 3 years ago at Black Hat, and so obviously it is sometimes you would like to apply all the variants, all the payloads based on this data, and in case of sessions and some kind of hex data, my neural network trained by this payloads try to suggest memcached injections because of this hex encoded data. This network understands that, so probably it is kind of hex context, and this context in the past was addressed asked to some sort of key value injection inside memcached, it is really great time to suggest some kind of new line injection and put some sort of key value things there, which is really cool. So what's next? As I mentioned before, my next goal is to solve results analysis problem by neural networks as well, to not only generate payloads, but also to analyze the results, to suggest what is normal for this particular app, what's abnormal, and how to generate some sort of exceptions there. Second idea after the first one, and it's also will be valuable when we can solve first problem, is how to connect it and automate with some sort of Python proxy, how to create a tool with the ability to solve all the things in automatical mode, and how to suggest this to you, because now it's just kind of command line Python script, and to be able to generate payloads, you should put this kind of string inside this like command line to receive this full string, right? My goal is to automate this thing and create some kind of tool, usable tool for everyone. Third one is to make it smarter by connection with responses, which means that if I have an anomaly with some sort of data, for example, I don't know, single quote, it is definitely, it's possible now to start to suggest SQL injection payloads, right? But when we are doing our payloads in the same context, for example, we already at the stage to brute column name inside a column. We should be able to send this information back to neural network with no hard coding, to ask them to generate new column name, to generate new like syntax construction instead of trying the same things. To be able not only generate payloads and to crash app to produce some exception, but to be able to automate this data extraction, automate this exploitation process at all, which is also possible. I believe that next year I'll present you something like AI-based SQL map with ability to steal data from anything, with ability to ask this network, for example, for some questions like dump this table or dump all the table, and this trained system will able to determine which database used at that case and how to extract and how to solve your task, how to extract this data, to not only identify that we have vulnerabilities there as this neural network can do, but also to automate this exploitation problem at all. And then I'd like to hack the planet as well. So, some sort of vision. So, let me please explain my vision because I still have 5 minutes. Yeah, so I have trouble with my, anyway. So, looks like I broke this. Next speaker should use something else. Anyway, who cares about next speaker? So 10 years ago, even 20 years ago, it was people versus people battle. And attackers were people and defenders were also people. Nowadays, we have AI-based defenders like, I don't know, Silence, some kind of companies with strange names, with Psi inside. Other companies based on AI. Some of them claim that they have an AI, some of them have some sort of an AI, but it is definitely possible to claim that we already have AI defenders, some sort of AI defenders. Yes, sometimes it's just marketing bullshit, but sometimes it's something reasonable. And now I try to reinvent this idea and try to suggest AI attackers. It is possible to generate fuzzing payloads. It's possible to generate some sort of data to crash the app, to identify vulnerabilities. And it's definitely possible, in theory, to automate all the attack exploitation process, from fuzzing to identify things, to steal the data, to have an access to the data, to exploit something, and to hack the planet at all. So that's all. Thank you.
Thank you. Any questions from the floor?
Yeah, I should mention that, so I'll publish all the results here at our GitHub. And this tool will be available soon, maybe tomorrow.
Okay. And if all right, here's one question.
Hi, thanks for the talk. That's a cool tool. How long did you train your...
You've never seen this tool.
It sounds cool. How long did you train your neural network?
So I should mention that since we are a commercial company, we have a lot of resources. But what is really good here is I'll publish all the trained results at the GitHub. It will be possible to download pre-trained neural network and start to apply them. But if you would like to train this thing from scratch, it's also possible, but it depends on your train set. For the many reasons, and so I have no way to disclose all the train sets because some of them based on our data from our clients, data from honeypots, and we have no any ways to disclose this data. But I'll publish pre-trained neural network, and I'll publish a tool how to train this neural network based on open source data like FuzzDB, FastXT, all these things.
Any other questions? That's a good one. Hang on.
Actually, in our case, it was 20 minutes, but I'm not sure that you have the same server. Up to 20 minutes, yeah. But I have 25 NVIDIA cards at one server. Don't ask me how. Don't ask me how. Just for free. Really, really. I have good friends.
Great friends, it sounds, huh?
Yeah. The next question should be how to find these friends.
Come to Hack in the Box, she said.
Yeah, sure.
And what kind of data must we send on inputs?
Yeah. So funny thing here that you are able to put any kind of data. I have two different strategies here. First, it's put data from your test. For example, sessions or like your login. And neural network should understand that it looks like session means hex encoded data. I should apply like memcached injection here. If it looks like, I don't know, HTML code, I should apply SQL injection or like XSS. If it looks like SQL injection already, for example, data from PHP-MyAdmin, it's definitely a bad way to apply SQL injection here. It works even without us, right? But my second strategy, as I mentioned before, is to run simple one-byte fuzzer first, find anomalies there, and apply the results of this abnormality to neural network to generate the continuation of these generations. It's better than try to use another approach. So, as I mentioned before, at the slides, it's definitely recommended to apply some sort of, let me show, yeah, this sort of fuzzing using like complete fuzzing based on 2 bytes half fuzzing, which means that we are able to split all the bytes from 7F to FF and run this fuzzing, generate some kind of abnormality, and run this neural network using this some sort of data. But it's also possible to use this first strategy and run them based on your data from your request, normal data actually. It's also possible.
Thank you.
Any further questions? No? Well, thank you very much, Ivan, for a great talk and for announcing the release of Neuralfuzz at HITB.
Follow our GitHub. Thank you.